Good morning. Let's check out section 4.4, sinusoids. Sinusoid is sine or cosine. They basically look the same. They just shift it a little bit. We'll chat about that here. So, sinusoid graph, and maybe you've graphed sine before. We've done it in class before, and you've seen that. It looks like this. So I'm going to give a basic diagram, and then we'll refer to this as we go through. So, sine and cosine are periodic, which means they repeat after a little while. So you'll do this, and then if the graph continued, it would just do the same thing again and again and again and again and again forever and ever and ever. It repeats. It repeats, and then it repeats, and then it repeats. The form of the equation we're going to talk about is A sine B x minus h plus k. And by the way, cosine, this is just a note. Note, cosine of x is equal to sine of x plus pi over 2. Whoops, sine of x plus pi over 2. So if I'm talking about cosine, you can just shift sine over a little bit. Remember, adding 90 degrees at the x moves the graph left 90 degrees, or pi over 2. So cosine is just moving sine to the left a little bit. That's all. Or that's all, yeah. I mean, you know, that's how you would do it if you wanted to. So many of these will apply to both the functions. First off, the amplitude. Okay, that is A. That is the height of the wave. So if I go up here and I go there and I go there, and that's A and that's negative A. Okay, that is the height there. That's how low it goes there. And there's the amplitude of the wave is A. Okay? The total range will be from negative A to A, or a difference of 2A. Okay, so the amplitude is just from the axis to the top or from the axis to the bottom. Amplitude is half of the total height. The period is 2 pi over B. Oh, this is the height. The period is 2 pi over B. And I guess I should put both of these in absolute values. Always absolute values there. The period is 2 pi over B, and how long it takes to repeat. How long it takes the graph to repeat. Okay, how long it takes the graph to repeat. So this is, the graph goes this far, and then it starts to repeat itself right here. So this is 2 pi over B. That value right there is 2 pi over B. If B is 1, then the graph repeats after 2 pi. So if there's no coefficient in front of the x, then it will do what we think it will. It'll just repeat after 2 pi. We put in 1 for B. If we want it to repeat after just pi, put a 2 for B. And then we'll repeat every pi. We can horizontally compress the graph to fit our whims. Frequency. Frequency is B over 2 pi. Okay, it's the inverse, it's the reciprocal of period. And the frequency is how often the graph repeats per unit. How often the graph repeats per unit. Okay, well, what does that mean? In this case, 1, if I was looking for 1 on the graph, it'd probably be right about there. Now, how often does the graph repeat before it gets to that part? That's actually just a small fraction of the graph itself. So if the graph was very busy and I had lots of sine waves here before that point, then it would make a little bit more sense. Let me speak about frequency in a different way. Frequency is how we measure computer processors in hertz and megahertz and gigahertz. That's just how many times the cycle That's how many times it can add or subtract something per second. So the frequency, a different example we'll look at will illustrate this a little bit better. But it's basically, let's see. Let me do another example over here that'll make a little more sense. Okay, let's say there's one. And let's say my graph is moving very quickly. Oops. Okay, so I get 5 copies of the wave between 0 and 1. So the frequency here will be 5. Because there are 5 sine waves before you get to 1. So this is a better example than the one we have at the top of the page to talk about frequency. Frequency is how often the graph repeats per unit. Okay, 1 hour, 1 second, 1 whatever the context is. You need to use your imagination here for a minute. Finally, phase shift. Phase shift, that is H. That is a horizontal translation, that's all. So when we have a horizontal translation, hang on, I can't think him right. When I have a horizontal translation of a graph, well, we call that a phase shift when it is a sinusoid, and that is just the value of H. So let me go back up there real quick. Okay, so this is your vertical translation. This is your, this is your horizontal translation. This is your vertical translation. In the horizontal translation, in a sinusoid, we call a phase shift. So that's what that is, and that's it. Choo!